Yes, dear audience, we are living in an era of policy-relevant science, and that often means that we are starting to use all kinds of buzzwords like sustainable development goals and ecosystem-based management and spatial planning and blue growth. And a while ago, I was in a seminar, high-class seminar on blue growth, which was organized in the harbor of Helsinki, which is the biggest harbor in Finland. And there was the CEO of the harbor explaining how the operations in the harbor are going. And in the end, I asked him, how do you see blue growth in your work? And what do you think about blue growth in general? And he stared at me and said, nothing. I don't even know what it means. My task is to make the operations in the harbor work and the ends meet financially. So this is where we are. Only by making everything practical for the practitioners of maritime activities, for the planners, and for us all. That is the only way we can succeed in implementing these buzzwords. So, the key question in spatial planning from the point of view of environment is, are there spatial conflicts between high nature values and human activities? And that in practice means that if you want to avoid destroying important habitats, you need to know where they are. If you want to know or avoid destroying the rarest species and the functions of the ecosystems, you need to know where they are, how they are distributed, where are the key functions, and how does this system work. So in the Baltic Sea, that is not so easy. If you look at the archipelago area of the southwest Finland, it's really very complex. If we are looking at this 80-kilometer long area and zoom in, it's the whole picture here, the red area, the next picture, and the next picture. And you start to think, where am I trying to look at my habitats? Where are they? Where are the most important species, and how does this system work? Well, how do you do an inventory in this kind of area? Zoom in even more, and you are in the reality. This is an area in Åland Islands, and now we are starting to think where we are putting our sampling points in this environment, and how does that represent the whole environment from this a couple of 100-meter scale to kilometer scale, 10-kilometer, and basin scale. So, well, that is almost a mission impossible, but we tried anyway. In the beginning of 2000s, this so-called Velma Program started, and in 2010 we got a little bit more money from the government and made a comprehensive inventory plan for the whole coast of Finland. And it included about 17,000 observation points, some 50,000 more densely aggregated grid points in important areas, and even that is not enough. You need to go to spatial modeling. And the data was collected by geological methods, echo sounding, and quick and dirty video methods, and scuba diving. And in the end, we have a lot of maps on environmental variables, like in the upper picture, water temperature, at the bottom, measured temperatures and modeled temperatures. There's one species, eelgrass, in the lower picture. Then in the end, we can have, after the inventories, geographical distribution maps based on observations, like here, blue mussel. You can see that it does not exist in the Bay of Bothnia or the eastern Gulf of Finland at all. And in the end, you can create biodiversity maps out of that information. All this is now published in our map portal. Just Google Velma map portal if you are interested, and all this information is available online. But then, how can this information be used in marine spatial planning? I have two examples. The other one comes from southeast Finland, Kymmene regional plan. You can place all this information on important habitats on a map, and the green ones are biological parameters like indicator species. And then you ask yourself where you are allowing human activities. For instance, these yellow circles are the ones where you could allow dredging and landfill. And the final regional plan looks like this, a close-up of it. There's geodiversity, protection, wind farm area, cultural heritage, etc. Okay, this is how it could go. Another example is multi-use of ocean space. That is another buzzword. Very, very futuristic ideas of how the sea space could be used by placing different things in the same areas. Well, we have a project called Smart Sea, Gulf of Bothnia's resource for sustainable growth. There's one particular problem, location problem, wind power, for instance. These are the current wind power places, and these are the ones under planning. And there's a lot of people that don't really enjoy having big windmills around their vicinity. So the question is whether some of them could be placed in a windmill park. But the question is where to place it. And we are building a spatial planning tool where you actually are calculating the technical parameters for the windmill placement, depth, habitat on the bottom, how easy it's to build, what are the wind conditions, logistics for electricity cables and service, etc. And then taking into account all this nature information from Velma Program and trying to figure out what are the most suitable places for offshore windmill building. So this highlights another example of spatial planning in practice, how it could be done when you have enough information on technical and economical factors as well as nature. So to conclude, we have collected a lot of knowledge on geology, habitats and species that can be used in maritime spatial planning, and the other example is of the multi-use of ocean space. Thank you for your attention.
Thank you very much, Markku. Here we can see the kind of dilemma we have when there are lots of mutual interests for certain areas also. There's time for one question here from the audience. Please.
Yes, good point. Our inventories have been started in 2004, so it's obvious that some of the habitats have probably changed. We did most of the work in 2011 to 15, and the funding was 1.3 million euros per year. So it's not really that much. We could do it in a relatively cost-efficient way by doing it like this. But then again, yes, you are right that in 10 years the habitats may have changed for various reasons, and then we are starting Velma 2 right now as we speak this year, and that means that we are going in some areas of which we do have not know or get enough information, and also we are organizing biodiversity monitoring based on the information what we have, because the spatial information allows you to define areas that are representative for a certain larger area, and then repeating the observations, let's say every 2 years in the same areas, but on a restricted area is not very expensive, but you can get a new picture of the situation in the area anyway. So yes, you need both spatial inventories and the monitoring to get enough information for spatial planning.
Okay, thank you very much, Markku. Oh, here's a small gift to you also. Thank you for this.
Thank you.